All right, this is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and don't share contact information during class for your own security reasons. Make sure that you are participating, since that always helps. All right, so at this point, make sure your attendance ticket is open, your attendance check is open, and you've entered your start of class word. Link is in the chat box along with the start of class word. Sorry, I'm a little bit sick, guys. Go ahead, give me green checks. Waiting on Alan, Andrew, Benjamin, Candace, Chloe, Chris. Thank you, Candace. Waiting on Enrique, Gabriel, Holly, Jazz. Green checks, please. Ayana. Let's see. Oh, Ayana, you just joined us. Let's see here. MJ, Michael, Jones, Ray, Raby, Tatiana, Trent. Green checks, everyone. Z, make sure you unclick your away button if you are back. Please and thank you. Looking good, everyone. All right, so let's keep on going here. So we are officially at the point where there are only 15 days left of the quarter, which means that we are 2/3 of the way through the quarter. It is almost over, everybody. That means that the class is also almost over. So hopefully that makes you a little bit sad, but mostly happy. So we are talking about Unit 7 for most of this week. We will be starting Unit 8 on Friday. And keep in mind, there are only 9 units. So we're finishing up the rest of our units next week. And then all we have left is our final exam. Oh, man. All right. So there's a lot going on here. Let's make sure that we are ready for this. Today we are talking about waves. So we are jumping into our waves unit. So we are taking a look, take a look at our calendar here. Remember, the quarter does end on the 28th, Monday the 28th. Courses close at 11:59 p.m. And will I accept any assignments after this time? Will I accept any assignments after this time? Yes, everybody does the final. It is the last big assignment. Remember, there are 10 big assignments. The final exam is the last one. Although it is worth the same amount as all your other exams and labs too, so if you've been doing all of those ones too, you should be in a really solid place. It's not like a make it or break it exam if you've been doing everything else. Cool. All right. So no assignments will be accepted after this point, so you need to make sure everything's turned in. Again, the last day of the quarter is also the last day of the class of this course. Give me a smiley face if you feel good about that, if that makes sense. Confusion face or thumbs down if you have any questions. Awesome. Thank you, Lolo. Thank you, Enrique, Drea. Perfect. Thank you, Holly. Looking good. All right. So we are starting our unit on waves. All right. So we are taking Connor, you gave me a telephone. I don't know what that means. So we are talking about waves for this unit. So we're going to take a look at the properties of waves, talk about some different kinds. We're going to define a bunch of vocabulary like frequency, wavelength, and pitch, and then talk about the Doppler effect, which is something that you actually have probably experienced quite frequently whenever an ambulance or a fire truck has passed you, which I live in like South LA, so they pass literally all the time. It's just background noise at this point. So today we should be able to compare and contrast mechanical and electromagnetic waves. We should be able to give examples of the different types of mechanical waves. We should be able to define crest, trough, amplitude, and wavelength and understand the relationship between period and frequency. And here is our agenda over here. Okay, so at this point, we should have our notes open. Let's go ahead. I'm going to send out the link for your notes. Give me a green check if they're opening for you. Red X's if you're having any issues with that. Yeah, Lola, you want to move to LA? Do you want to be an actress? I feel like that's why a lot of people want to move to LA. It's nice. I mean, nice weather. There's only like two hot weeks during the year. Oh, yes, a model. I knew that. All right. I got close. Ichiraku ramen. Right now, yeah. Yeah, Connor, I would say the best part's probably the weather, but everything else it's very crowded. Unless you're like extraordinarily rich and you live in the really, really nice areas. Yeah, as a teacher, that's not going to happen for me. All right, green checks, everyone. Again, make sure your notes are working. Red X's if you're having any issues getting your notes to work. All right, I'm only seeing green checks, so I'm going to move on. The links are still in the chat box, so keep on getting those open as we go. So we're going to start talking about waves, all right? So first, let's go ahead and observe a stadium wave. How many of you have ever been a part of a stadium wave? Tell me in the chat box. Have you ever done a stadium wave before? at like a football game or a football game. Yes! So stadium waves are lots of fun. So I'm going to go ahead, I'm going to show you a video, and I want you to tell me all of your observations. So take a look at what's the wave doing, what are the people doing, what do you see happening? So make your observations. I'm going to turn off my video and turn this one on. Here we go. All right. Should be finishing up. Tell me in the chat box, what did you observe? All of your observations, what were you seeing? I know, always fun to watch. I know, a lot of pixels, right? All right, what did you observe? Tell me your observations. Yeah, so hopefully you saw the wave moving, right? Started across the stadium, but how was it moving? Tell me in the chat box. How was the wave moving? It started across the stadium, and then what was happening? Did you just stay in one spot, or what did we see? Everybody in the chat box, I need you participating. I need you typing. Tell me, what did you observe? I got an answer from Connor. I see Candace typing, Lolo typing. Yes, we saw people stand up and go down. Yes. The wave moved, right? It moved from kind of like the side to side around the stadium, right? So we saw the wave move around the stadium. Awesome. Let me go ahead and type this stuff up, right? So we saw a wave moving around the stadium, and what we saw were the people were moving up and down, right? Waving their hands. Awesome. All right. Any other observations that we made? Tell me in the chat box. Any other observations that we made? Yes, no. All right. So what I want you guys to think about is the wave was moving around the stadium, but were the people sprinting with the wave? Tell me in the chat box. Were the people actually running around the stadium with the wave? Were the people running around the stadium with the wave? No, right? The people stayed in their seats. So the people stayed at their seats. They were moving up and down, but at no point were they actually moving with the wave. So this is really interesting. We want to think about how can a wave move around a stadium without the people themselves actually having to move with the wave? Give me a smiley face if that question is beginning to make sense. All right, because that's what we're going to talk about today, and it should kind of blow your mind. Like, how can the wave move without the people themselves actually moving away from their seats? Okay, cool. So here's what we're going to talk about. So waves transfer energy. No matter what type of wave it is in terms of physics, mechanical waves or electromagnetic waves, they all transfer energy. So both transfer energy, both mechanical and electromagnetic waves. Now, how are they different though? So mechanical waves are what we're going to focus on in Unit 7. Electromagnetic waves are what we're going to focus on in Unit 8. So this unit, we're going to take a look at mechanical waves, which are waves that require a medium or matter in order to move. So this means they need a physical substance. They need water. They need the air. Air is made up of particles, so it's a physical substance. They need gases. They need other liquids. They need solid materials. They can travel through the earth because earth is a material, a physical material. Give me a smiley face if that's beginning to make sense. Okay, so mechanical waves need a medium. They need something physical to move. Now, electromagnetic waves, we mentioned this in our last unit when we talked about heat, because electromagnetic waves have radiation that can transfer heat without using a physical substance. So they do not require a medium, and they can travel through a vacuum like outer space where there is no matter. There are no particles, there's no air, no substances that those could travel through in outer space. All right, so for example, this is light waves. So electromagnetic waves are also called light waves, and light can travel to the Earth through outer space without a medium. Light does not need a physical substance. In fact, physical substances stop light. All right, give me a smiley face if that's beginning to make sense. Smiley face if that's beginning to make sense. All right, so mechanical waves need a medium. Electromagnetic waves don't need a medium. They can travel through a vacuum. They're called light waves, and all of these transfer energy. They both transfer energy. Fill in the blank here for number 1 in your notes with the word energy. You have 20 seconds to give me a green check. I'm going to clear out your old ones. Ready, set, go. Perfect. All right, waiting on a few more green checks. Again, if I'm not getting green checks from you multiple times in a row, I'll move you to the check-in room so that I can then check in with you. All right. Waiting on Alyssa, waiting on Amanda, Andrew, Antonio. Green checks, please. Thank you, Antonio. Waiting on Chris, Daniel, Enrique, Erwin. Let's see here. Gabriel. Let's see here. Ayana, thank you. Waiting on Josh, Kayla, Nani, Kirsten, MJ, Jones, Ray. Shh. Tatiana, Trenton, say hi. No, you don't want to say hi? Say hello. Can you wave? No, you can just be grumpy. All right, looking good, everyone. All right, so let's go ahead and talk about this. Go ahead, match these up on the board. We just talked about the properties of mechanical waves, electromagnetic waves, and both waves. Go ahead and match those up. Which ones don't require medium? Which ones transfer energy? Which one require medium, like air, water, or earth? Which ones can move through vacuum like outer space? And which ones are also called light waves? Go ahead and match those up for me. Work quickly. Use your line tools, your whiteboard tools. I see Z on the board, Ayana on the board, Lolo and Holly, Andrea and Marlene. Thank you for your participation. Looking good. Let's get some more participation up there as well. I see Candace on the board, Ivy on the board. Perfect. There we go. Oh, can't even trip you guys up. These look so good. Awesome. Okay, I'm going to pause the tools up here, and then we're going to match these up, make sure these are correct, and this will be number 2 in your notes, so get number 2 in your notes ready to go. Here we go, moving this. All right, so mechanical waves. Mechanical waves, yes, mechanical waves require, oops, let me grab my red tool. Require a medium like air, water, or earth. Absolutely, right? Remember, we talked about mechanical. They require a physical substance, all right? Electromagnetic waves, on the other hand, do not require medium, meaning that they are therefore able to move through a vacuum like outer space where there are no physical substances, and they can also be called light waves. Electromagnetic waves are also called light waves, like from the sun, and then both of these transfer energy. Remember, all types of waves in our physics class transfer energy. So you have 45 seconds to either complete number 2 or get a picture, and I need green checks from everybody. Go, go, go. 5 more seconds, need your green checks. I will begin moving people into the check-in room soon now that we've had a few opportunities to participate. Need everyone's participation, please. All right, waiting on a participation from Alyssa, Amanda, Andrew, Kayla, Chloe. Green checks, please. Chris B. Waiting on Daniel, Diego, green checks, please. Gabriel, Jackie, Kayla, Nani, Kirsten. Let's see, Lolo, green check, please. Jones, Ray, C, Tatiana, Trent, green checks, everyone. Let's get to work, please. All right, Trent, make sure you're getting your green checks so I don't need to move you to the check-in room in the future. Thank you. All right, looking good, everyone. Let's keep on moving here. All right, so mechanical waves do not move matter from one place to another. This is really important to understand, okay? So this actually has to do with our stadium wave. So that's why we started out talking about a stadium wave. So in a stadium wave, right, the wave moves around the stadium, but the people themselves do not run around the stadium with the wave. Instead, all they need to do is stand up and sit down, but they never move away from their seats. So in the same way, a mechanical wave, as the energy travels through the substance, the medium's particles, the substance's particles can go up and down, they can go back and forth, they can even go in circles, but they do not travel with the wave. They kind of stay in their seat, right? But only the energy moves. Give me a smiley face if that's beginning to make sense. Okay, so only the energy moves. Otherwise, the particles are just kind of moving up and down, side to side in their seat. So let's go ahead and take a look at an actual example of this. So this begins to make sense. All right, so let me go ahead and put this up on the board. All right, and tell me, what do you observe happening with the orange particles? I'll turn off my video to make sure that you can see this. What do you observe happening with the orange particles? Okay, there are 2 orange particles highlighted here. What are some observations that you can make? Tell me in the chat box. Awesome. I see Holly typing. I see Fro typing. An answer from Fro. I see Candace typing, Holly typing. What are the orange particles doing? Tell me in the chat box. What are the orange particles doing? Enrique's typing. Yeah, awesome. Getting some answers. Thank you. I see an answer from Z. Yes, they're moving in circles. They're spinning around. They're rotating. Awesome. But you can see that the energy is going from left to right, right? The wave is moving from left to right. But are the particles moving away from their spots? Are those orange particles ever actually moving away from their spot? No, again, this is really, really important. You've probably seen this, for example, like on the ocean, right? When a big wave goes by, or for example, surfers, when a big wave goes by, the surfers just go up and down on the waves. They don't actually move closer to the beach. Smiley faces if that makes sense. Smiley faces if that's beginning to make sense. All right, so the particles are just moving up and down in circles, but they're staying in their spot. Perfect. All right. So go ahead, fill in the notes for number 3 with the word particles. You have 30 seconds. Ready, set, go. 10 seconds. Screen checks, everybody. All right, need green checks from Amanda, Andrew, Antonio, Benjamin, Brandon. Brandon, I know you just joined us. Give me a green check once you have your notes open. Waiting on a green check from Kayla, Chloe, Connor, Ethan. Let's get a green check from Jackie, please. Jose, Josh, Kayla, MJ, Ty, Z. Green checks, everybody, for number 3 in your notes. You've either filled in the word particles or you have taken a picture, but I do need green checks from everybody. Green checks from everybody. Still waiting on Andrew. Are you there? Antonio, Brandon, Chloe. Need your green checks, please. Thank you, Antonio. Still waiting on Jose, Joshua, Kayla, Nani. Still waiting on Ty. Thank you, Ty. Perfect. There we go. Getting your participation. All right, Andrew, I'll check in with you. Looking good. All right, everyone. So let's go ahead and talk about this. So in a mechanical wave, the energy travels, but again, the matter itself stays in the same place. It stays in its seat. Now, there are 3 types of mechanical waves, and it has to do with how the particles are moving in their seats. So transverse wave is much like a stadium wave, where the particles move up and down. All right. So in this case, the wave is moving to the right, but the particles are moving up and down. So if that's the case, where the wave moves to the right, but the particles move up and down, is this parallel lines or perpendicular lines? Tell me in the chat box. Are these parallel or perpendicular? Let's get an answer from Fro. I see Candace typing, Holly typing. Yes, these are perpendicular, right? So the energy is going to the right, but the particles are going up and down. And so the particles are moving perpendicular to the energy, right? So anytime you see perpendicular particles moving perpendicularly to the energy, this makes it transverse. Smiley faces if that makes sense. So transverse wave is much like a normal wave that you would draw. So if someone asked you to draw a wave, you would probably draw a transverse wave where the particles go up and down. Perfect. Now, on the other hand, a longitudinal wave, the particles actually move along with the wave. So this is like a spring. Okay, so when you push a spring and the coils of the spring move through it, but they don't go up and down. So the particles in a longitudinal wave actually move parallel to the energy. So you can see that here, right? So if we have the energy going to the right, the particles move left and right so that they are parallel. Smiley faces if that's beginning to make sense. So the particles are moving parallel, also left and right. So we can see energy here and particles moving parallel. Particles are parallel. Okay, so that's longitudinal. Again, the way I remember that is longitudinal. Think about the word along. The particles move along a longitudinal wave. Now, surface particles, on the other hand, surface particles we actually saw in that GIF that I just showed you, and that is that the particles move in circles. So what's actually happening is the particles are combining both transverse and longitudinal motion to create circles. And these happen when surfaces touch. So for example, when the surface of water touches air, or the surface of earth touches air, or the surface of earth touches water. All right, so those are surface waves. Okay, go ahead, fill in the blank here with the word transverse quickly. We need to move fast. Fill in the word transverse and give me a green check, or you can take a picture and give me a green check. Go, go, go. 5 seconds work quickly. All right, waiting on MJ, waiting on Jones. I need a green check from Trent, Jose, Joshua, Kayla. Waiting on Jackie. I need green checks, Daniel. Thank you, Diego. Waiting on Enrique F. Waiting on Kayla, Chloe. Green checks, everyone. Looking good. Kayla, Chloe. Waiting on, thank you, Kayla. Waiting on Chloe. Enrique. Enrique F, Jackie, Jose, Joshua, Kayla, Nani, Jones, Trent. All right, let's go ahead and move a couple people. Thank you. Green checks, everyone. Perfect. Thank you, Nani. All right, let's keep on moving here. All right, so let's go ahead and break this down then. Let's take a look at this example. So take a look at a sound wave. So a sound wave we've actually learned about in our first unit. Sorry, not in our first unit, in a previous unit where we talked about energy. And sound, as it passes through the air, the particles vibrate back and forth so that they hit the next particle, sending the energy to the next particle, until it finally reaches the ear. And that sends those vibrations to your brain, and your brain is able to translate into the sound because your brain is amazing. All right, so let's go ahead and take a look at this. Take a look at these particles. Again, they are kind of moving back and forth, bumping the next particle to send all of that energy over to your ear. So they're bumping each other back and forth to send that energy to your ear. So take a look at this. Is the motion perpendicular or parallel? Are the particles' motions perpendicular, parallel, or I could say circular? Tell me in the chat box. What do you think? Are the particles moving perpendicular, parallel, or circular? Are the particles moving perpendicular, parallel, or circular to the energy? Right, so you can see I drew the motion of the particles up here. I drew the motion of the energy down here. I got an answer from Enrique. Yes, make sure you're answering, even if you're guessing, right? That's how we learn, either by getting it right or by making mistakes and then learning it right. Yeah, they're moving parallel to each other. So parallel means the particles are moving along with the energy. So in that case, is this going to be transverse, longitudinal, or a surface wave? Use your polling tools. What do you think? Is this a transverse wave, longitudinal wave, or a surface wave? Think about these. The particles are moving parallel. They're moving along with the energy. So is that transverse, longitudinal, or surface? Remember, we had that little hint of how that works. It moves along with the energy. Awesome. All right, I have about 11 answers. There are 46 of you. I need way more answers. Make sure we are participating, please. There we go. All right, there they come. All of those answers looking good. All right, let me publish these. Let's take a look at this. Looks like most of us said letter B. Some of us said letter A, though. That's fine. Let's go ahead and take a look at this. So longitudinal wave is the correct answer. And the reason a longitudinal wave is the correct answer is because the particles move along with the wave. So remember, long and along. That should help you remember that. So longitudinal waves, particles move parallel, back and forth. Smiley faces if that's beginning to make sense. Again, much like a spring. The particles in a sound wave don't move up and down. They move side to side. Perfect. All right, this is number 5. You have 20 seconds to answer that and give me a green check in your notes. Go, go, go. Sorry, you have green checks now. 15 seconds, green checks, everyone. All right, need green checks from Alexis, Amanda, waiting on Andrew, Benjamin, Brandon. Green checks, please. Erwin, Ethan, and Jackie, Jazz, Kaylee, Nani, Jackie, MJ, Michael, Jones, green checks, everyone. All right, let's keep on going. All right, so now let's go ahead and take a look at this one. So a Rayleigh wave is a seismic wave that's caused by earthquakes. And this is where the earth meets the air and the particles travel as shown below. So take a look at how the particles moving in this diagram here and tell me, what do you think? Is this a transverse wave, a longitudinal wave, or a surface wave? Take a look at the red diagram right here, the red particle motion. And think about what kind of motion is that particle, and therefore what kind of wave is that? Again, take a look at the particle motion and then guess what type of wave would that be. Excellent. All right, I've got 8 answers so far, 47 of you. Keep on working. What kind of wave do you think this is? Take a look at the red particle motion. Again, it doesn't matter what it looks like overall, it matters what each particle is doing. So pay attention to the particles. Awesome, thank you, Fro. I see you in the chat box. Yes, let's publish these up on the whiteboard and clear out your old answers. Yes, the correct answer here is C. Looks like most of us chose that too. This is a surface wave, and tell me in the chat box, how did you know this was a surface wave? Let's connect it all together. Tell me in the chat box, how did we know this was a surface wave? What about that particle motion kind of gave you that answer? Not exactly up and down. Remember, transverse is up and down, right? So the particles in transverse move up and down. In longitudinal, they move side to side. In a surface wave, they move, yes, in a circle, Enrique. Yes, Drea. So when we take a look at a surface wave, we want to look at the individual particles. And you can see here the particles in this wave are moving in a circle. Smiley faces if that makes sense, everyone. So you can see they're moving in a circle, kind of moving like this, right? Awesome. This is the answer to number 6. Again, you have 20 seconds, green checks, and then we're going to go ahead and talk about some important vocabulary. Go, go, go. All right, green checks, please. Alexis, Amanda, Andrew, Antonio, Benjamin, Brandon, Candace, Connor. Green checks, please. Gabriel, Fro, Ayana, Jackie, Jazz, Jose, Nani, Lolo, MJ, Jones, Ray, and Trent. Green checks, everyone. Thank you, Candace. Perfect. All right, again, still waiting on Jazz, Jose, Nani, still waiting on MJ, Ray C, Trent. Green checks, everyone. Looks like I got most of you. Awesome. All right, let's keep on going here. All right, so now we're going to talk about some important wave vocabulary. So what I want you to do is on the whiteboard, grab your pointer tool or your writing tool, and I want you to find me the highest points, the lowest points, and then we're going to make some observations about what we observe about the highest versus the lowest point. So either point, circle, label, put it on the board. Where do you see highest point? Where do you see the lowest point? Do you see more than one? What are you observing? Go ahead, write your answers up on the board. Highest point, lowest point. Label them. And then if you want, write your observations on the board, or you can write them in the chat box. Let's see who I've got participating up there. Looking good. I see Lolo on the board. Up there, please. This is an easy one, guys. This has nothing to do with physics yet. I'm just asking you to identify where are the highest points, where are the lowest points. Awesome. I see Jones on the board. Marlene, Candace, Z on the board. Looking good, looking good. Label them for me. Excellent. All right, good. So I do see that you've labeled all of them so far, so we can see all of our high points, all of our low points. Perfect. And now tell me, what do you observe about the high points, the low points, or this wave in general? Take a look at this transverse wave. Tell me in the chat box, what are some things you observe? You can also type them on the board in any empty spot. But what are you observing? Yeah, so we can see some repetition, right? That's what I'm assuming you're saying, right, Lolo, is that you can see some repeating parts, right? So we can see multiple high points that repeat. We can see multiple low points that repeat. What else do we notice? Take a look at the height of the high points versus the depth of the low points. What do you notice about that, right? We've got this kind of line here. What do you notice about how high the high point is and how low the low point is? In the chat box. Make those observations. All right, I need to see typing and participating. I'm going to wait for 3 answers, and we're just going to wait for people to answer. Otherwise, we will stay here. In the chat box, I need your observations. What do you notice about how high the high point is versus how low the low point is in comparison to each other? I see Connor typing. I see Z typing. Thank you. I see Candace participating. Let's get some more answers. Let's hear from Alan and Alexis and Wes and Ty and Ayana and Nani and Jones. I see Riley typing. I see Holly typing. What other observations do you notice here? I see Kayla typing. Yep, we can see a pattern. Candace typing. Again, you guys can have same answers. You can have similar answers. What else are we seeing? Awesome. Yeah, we can actually see that they're the same distance, right? So we can see the height. So the high point, and the low point are the same distance from the center line. Smiley faces if you observe that as well, right? They're equal distances. The high point is the same distance away as the low point is. Awesome, looking good. All right, so that's all important because this is going to help us understand the vocabulary behind a wave. So the crest is the point on a medium, with the medium meaning the substance, with the maximum upward displacement. Let's break that down. So maximum means the most, upward means going up, and displacement means the distance. So in other words, it's the highest point on the wave away from the equilibrium. So you can see here that we can see multiple crests right here. So the highest point. And again, crests are just points. They are not distances or anything. They're just single points on the wave. Smiley faces if that makes sense. So crest is just the single point on the wave, the highest point. Okay, now troughs are the opposite. Troughs are the points on the medium with the maximum downward displacement, right? So those are going to be the lowest points away from the equilibrium. And again, those are just actual single points. Single points. So you want to imagine a crest like the crest of a wave, an ocean wave coming towards you is the top of the wave. And you want to imagine a trough is like a horse trough that you might fill up with water. So it's the maximum lowest point. So think about trough is going to look like you could fill it up with water. All right. Now, so we talked about the actual points, but now we actually want to talk about some measurements. So the way that we can measure things are with amplitude and wavelength. So amplitude is the actual height to the crest from the equilibrium, or the height from the equilibrium down to the trough. And these are actually equal to each other. You can see this here. So again, the amplitude is the height up to the crest, or the height or the depth down to the trough, and they are both equal to each other. So we can measure either way. Now, what I want you to understand is the greater the amplitude of a wave, the more energy it has. Imagine you have an ocean wave coming towards you. Now, the ocean wave is currently the height of your knees. Do you need to move? Tell me in the chat box. If you have an ocean wave coming towards you, it's about the height of your knees. Do you need to move away from it? Yes, no. What do you think? Tell me in the chat box. I see Riley typing. I see Marlene typing. No, most likely not, unless like there's a shark in that knee-high water, right? Maybe if you don't like water, right? But for the most part, it's going to hit you, but it's not really going to hurt, right? So you're not going to get injured or anything. You're going to be fine. Now, on the other hand, let's say you have a wave coming towards you that's 3 times as tall as you. Do you need to move? Yes, absolutely. And why do we need to move if it's 3 times as tall as us? Right? Why do we need to move if it's that big, if it has that big of an amplitude? No, you should move, Lola. Why should we move? Tell me in the chat box. We have a huge wave coming towards us, really big amplitude, really big height. Why do we move away from it? Right, because it's going to hit us and it's going to hurt, right? It's going to smash us, possibly crush us, possibly really, really badly injure us, okay? So the greater the amplitude, the taller the wave, the more energy it has. That's why we move out of the way of the big waves. But this is even true with like sound waves, right? Whenever you see like the DJ like mixes with the sound waves on their computers, you see that the really loud sounds are really big. They have lots of energy. They're really big, okay? Now remember, the crest and the trough are just the single points, right? From the single point at the top or the single point on the bottom. The amplitude is the actual height to those points. Give me a thumbs up if that makes sense. So crest and trough are points. Amplitude is an actual height that you might say like it's a 3-meter high wave. Okay. Now wavelength is an easy one because it's the length of a wave, right? So it's a wavelength. Okay. So it's the length of one complete wave cycle. So we noticed in the previous observations that there is repetition, right? There's a repeating pattern of waves. So if you take just one part of that pattern, just one single cycle, and you measure the distance from where it starts to where it ends, that is the wavelength. And you can measure this in multiple ways. So you could measure this from crest to crest. All right, so we can see that here, crest to crest. You can measure this from trough to trough, and then it begins again. Or you could even measure this from like in terms of bumps. So you could measure where you've got one top bump, one bottom bump, and then it repeats again. And this right here would again be the same wavelength. Thumbs up if you can see that again, that these wavelengths are all the same. Actually, give me smiley faces if that makes sense. So no matter where I measure, as long as I measure from the starting point to the ending point of a repeat, it will always be the same wavelength. Excellent. All right. What I want you to do, go ahead, grab your whiteboard tools, grab your letter tools, and I want you to go ahead and write which one is the amplitude, which one's the crest, which one's the trough, which one's the wavelength. Remember, 2 of these are points and 2 of these are actual lengths or distances or heights. All right, go ahead and put those up on the board, right? You have a bunch of empty space, so you can write it wherever. So I should see a bunch of A's, a bunch of B's, a bunch of C's, a bunch of D's. See Candace working on the board, Marlene working on the board. Riley working on the board. Jones on the board. All right, looks like we've got crest. If we know crest, we should be able to figure out trough. What is the trough? I see Ethan working on the board. All right, so we've got crest and we've got trough correct. I'm going to pause your tools really quickly. We actually have amplitude and wavelength incorrect. So we need to fix amplitude and wavelength. So On the whiteboard, go ahead, fix those up for me. You have your tools back. So amplitude, think about what the amplitude is. Wavelength, think about what a wave length is. Wavelength. The definition is in the word. Awesome, looking good. All right, let me go ahead. I'm gonna put this up on the board. You can keep on writing your answers up there. But letter A is the crest, right? A single point, which is the highest point, is the crest. Letter D is the trough because it's the lowest point. Letter B is the height, otherwise known as the amplitude. And then wavelength is the length of the wave. So that would be letter C right here, which is wavelength. Excellent job. Go ahead. Answer number 7 in your notes. You have 45 seconds. Green checks when you have that saved or you've taken a picture. Go, go, go. All right, waiting on Amanda, waiting on Andrew. Need green checks, please, from Kayla, Brandon. Green checks, please, Chris B. Waiting on Jackie. Hi, Anthony. Welcome to class. Waiting on Jazz, Jose, Kayla, Marlene, MJ, Jones, Ray, Sarah, Trent, Ty, and Wes. Green checks, everyone, for number 7. You've either answered it or you've taken a picture. All right, looking good. I've got most of my green checks. Here we go. Let's keep on moving. All right, so the last thing we need to talk about is period and frequency. So period is a period of time. Okay, yeah, no worries, Anthony. I'm glad you were able to make it. All right, so period is a period of time. Like if someone asks you, oh, what time period did people wear really floofy dresses? You might say like the 1800s, right? Smiley face if that makes sense. So when you think of a period, you should think of a period of time. Period of time. So that being said, what a period is in physics is that it's the time it takes for a single wave cycle to be completed. Okay, so it's the time for just one wave to happen. One wave cycle. Okay, so take a look down here. If we have one period right here, okay, so we can see one period right here from the start of the top bump to the end of the bottom bump. And you can see that there were 3 waves in a single second. We got to divide this out. So take a look here. So we've got 1 second, but each wave here. So take a look at just this part. How long did this single wave take? Tell me in the chat box. Take that 1 second divided by 3 and tell me how long did that one wave take? 1 divided by 3, grab a calculator, use some mental math. What is 1 divided by 3? How many seconds did that single wave take? So we're dividing this second by 3. Awesome. I see Connor typing. I see Candace typing. I see Jones typing. Awesome. There we go. We're getting some answers here. Yes, so the period right here equals 0.33 seconds, a third of a second, 0.33 repeating seconds. Perfect. Now, frequency, on the other hand, is the opposite or the inverse of period. So frequency is the number of overall cycles in 1 second, right? So period is a period of time for one cycle. Frequency is the actual number of cycles in 1 second. All right, so we measure this in cycles per second, or we shorten it to call it hertz. All right, so hertz, Hz. So take a look. What is the frequency below? Here's 1 second. How many waves do you see happening in 1 second? Count them out. How many wave cycles do you see in this 1 second? Tell me in the chat box. Perfect. Take a look here. Yeah, you should actually see 3 of them, right? So we start with the top, end with the bottom, start with the top, end with the bottom bump, start with the top bump, end with the bottom bump, for a total of 3, right? Here's 1, here's 2, here's 3. And so here the frequency is 3 hertz, or 3 cycles per second. 3 cycles in a single second. No. Connor, it's both the top and the bottom. All right. Now, period and frequency are related, but they are not the same. So again, period is the time for one cycle, and it's measured in seconds because it's a period of time. Frequency is the actual number of cycles, total cycles in 1 second, and that's measured in hertz. All right, so let's go ahead and match those up for me, and then I'm going to go ahead and dismiss you with your end of class word. Go ahead and match these up for me. Amplitude, crest, frequency, period, trough, and wavelength. Right, so which one is the height? Which one is the highest point? Which one is the length? Which one's the lowest point? What's the time for one cycle? And what is the number of cycles in 1 second? All right, I see Ayana on the board, Ethan, Chloe, Anthony, Drea, Candace, Awesome. I see Ivy on the board. Thank you, Andrew. Oh, it's getting a little messy. Okay, so again, amplitude is not a length from crust to crust, right? The length is the one that has the word length in it. I feel like we keep on making that mistake. It's okay, we're learning from it. So amplitude is not the length from crust to crust. It is a distance, but it's not a length from crust to crust. It's the other one. So think about what the other one is. Awesome, looking good. Gonna pause your tools in just a moment. Let's fix amplitude though. Yep, let's continue fixing amplitude, please. Looking good. There we go. Loving it. All right, I'm going to pause your tools here, shrink these down a little bit. And let's go over our answers here. So amplitude, yes, amplitude is the height. Okay, amplitude is height. Remember we talked about big amplitudes, right? Like think about like an amp. The purpose of an amp is to make sound louder. So amplitude is height, it's the energy, it's how big of a wave it is. Smiley faces if that helps you remember amplitude. I should remember that. Amplitude, think about a sound amp. It's the height of the wave, how big it is. Awesome. Now crest is the highest point of a wave. Perfect. Frequency is going to be the number of cycles in 1 second. Yes. Period is a period of time. So it's a time for one cycle to occur. Trough is the lowest point. And a wavelength is a length from crest to crest and trough to trough. This is number 8. Give me a green check when you have answered this one or saved it. You have 45 seconds. Go. Answered it or taken a picture. I have about half of them so far. Thank you, Antonio. Waiting on Kayla, Daniel, Gabriel, Jazz, Jose, Kayla. Waiting on Nani, MJ, Jones, Sarah, Trent, Ty, Z. Green checks for number 8. Looking good. All right, I'm going to go ahead and move on and wrap us up. All right, so we talked all about mechanical versus electromagnetic waves, right? Those that require mediums, those that don't. We talked about 3 types of mechanical waves: transverse, longitudinal, and surface. Then we talked about all that different vocabulary that we just went over. All right, so how are we feeling? Put your pointer on the board. Where are we at? Very confused, still need help, pretty good, awesome. How are you feeling about those different things that we talked about? Looking good. All right. Looks like we're mostly falling in pretty good. Mostly falling in good. All right. Looking good. Awesome. All right. So I'm going to go ahead and stop our recording.